We've got quite an unusual set today from the same customer as the York 861, whose name's Barry, and this is an Amstrad CB900, not the 901. This has an advantage that there aren't any fake ones, and they're all the real thing. They're all made in Japan using the Cybernet 002 chassis, and it's even got a bit of a power lead with it, which is really unusual because it's a weird little plug. Now I wish any way you could get those. These originally came with those Action Man looking mics, and so they died a death very early on. They weren't very robust, and this has got a standard replacement coffin mic with it. So I'll tell you what, we won't use that. We'll use our mic at the moment. So we'll do all the tests on our mic, and then we'll worry about his mic at the end, just in case there's a malfunction on the mic. So Cybernet 002F chassis. So we'll get it all connected up to test gear, and we'll just see how it works. I think he said it's doing 3.5 watts. Let's just see what kind of fuse is in that fuse holder. Oh, none. I think he said there's something dodgy about the fuse holder, but it looks great to me. It's an RS type. Okay. Where's my little file that normally lives on here? Here it is. Just in case there's a bit of corrosion on there. That's better. And we want a suitable fuse. And there should be some on here. If not, I'll have to go and ask Mr. Chippy nicely for one. We'll worry about that later. So we'll connect this up. I think I'll get Mr. Chippy to do a better job and get rid of the chop block and splice that in a bit better. But I'm very satisfied. That's a very good type of fuse holder. We'll connect it to our power supply. So it's been negative to the lead and positive to the fuse holder, seeing as we've got no fuse. And switch the power supply on, and we've got it at 12.8 volts at 350 milliamps. So if there's any malfunction, we're not going to damage anything. So as I said, that the chop block fell apart. So I'll definitely get Mr. Chippy to improve this. So here it is, channel 3, pop it on channel 20, and the noise on the volume control. So we'll turn over the piece of paper, seeing it's the same customer, and this is Amstrad CB900. So we'll put picture in picture on. And you know what? I've plugged in the aerial instead of the test equipment. I don't think anybody's going to notice the 3-second blank carrier on channel 20. That's better. Well, this one's doing 3 watts on here as well. Frequency. Now let's hope this is a bit closer, because these are very difficult to get a bit extra out of. No, that's going to be alright. That's going to be alright. Deviation, wallow. That's very low. These are often ridiculously high. And then we'll look at sensitivity. Put the cyanide meter on. So 12 dB, it's doing 0.3 microvolts. Try the other scale, 0.3 microvolts. That's really excellent. Alright, we'll open it up. VCO is critical on these more than a lot of sets, so that's the first thing we'll do. And if I recall, it's done on channel 1 on these, whereas it's channel 40 on the Cybernet 134 variants. Excellent. So I think this is a service manual. It is. So we use this Amstrad service manual. I've also got the Fidelity 2001. So they're both Cybernet 002F chassis sets, but I seem to be using this more than the other. So VCO. Change my glasses so I can actually see what I'm doing. I've got my eye on the time because I've got another church service to do today. It's Sunday. So let's have a look. Channel 1. There we go. Test meter. One day the Aldi one will find its way back to this workshop. If this was the same source as his York 861, that hadn't been played with either. So far side of capacitor 9. It's always fun to get to this. Just make sure we've got a floating earth. I think we have. It's the same. So we're on channel 1, and it says here adjust transformer 1 to get 2 volts. Well, that's so close, you know, we wouldn't normally need to adjust it, but for the video we will. There we go, 1.99. So now we're going to transmit, and we should also have 2 volts. Except we've got minus 0.1. Well, that was well out, wasn't it? Back to receive, 2 volts. Back to transmit, 2 volts. Just make sure it's still transmitting. Yes, it's still transmitting. So now we go to channel 40 and we check. So we're on channel 40 and we should have 4 to 5 volts on transmit. We've got 2.7 and they don't tell you about receive. Now why have we got a lower voltage than I'm expecting? Let's go back to there. We've got 2 volts. We've got 2.7. It's a bit low. There you go. At least it's not in the minus. We'll keep an eye on that. I don't think there's a problem. Sometimes they don't quite set up as the manual says. Now this is a mess. It's got 2 resistors in the transmitter, which is far from ideal. We'll replace that. And the power's a bit low anyway, so we will replace that. I think these arrived yesterday, Amstrad power resistors. These have been on order for about 9 months. And these are ridiculously too big. The trouble is the specified resistor is 3 watts. And it's a 4-watt radio. So we move up to 7 watts. Just check what it should be. So I'm just going to run through the transmitter before we change any parts. So now we're on the 30-watt scale. We are at about 2.93 watts. Now that was peak, so we'll need to change that resistor. Right, that's that resistor changed, so let's see whether... I'll try and keep these as far away from the other components as possible. See whether we can get a bit more power. There we go, 4 watts. And that's dropped about 3.9 as it's warmed up a bit. Right, so the meter on the front, this keeps going on and off. I'm not sure where the loose connection is, and at this stage I'm not that bothered as long as I can get it to stay on. But I can't get it to stay on. So we want that to read 1 bar on low power. So it's reading 2 bars on low power. Now it's reading 1. Just for the record, it's 200 milliwatts for low power. It should be 400 milliwatts. It's not adjustable, and that's about what they usually end up doing. So now on high power we've got the full set of bars, but it's one on low power. Right, next, what we're going to do next? Oh yeah, deviation. Wallow, 1, 2, wallow, wallow, 1, 2. That's all right. Frequency. I hope this core isn't broken because I haven't any spares. There we are, spot on frequency. I didn't show you that. There you go, 27.79125 toggling switch 6. Done that, done that, done that. Excellent. Hoping we get some switch cleaning into that volume control. Right, first of all we need to do the detector. So we'll put it over to the oscilloscope, we'll switch the oscilloscope on, take the bench light off, and let's see if we've already got peak or what. The answer was not quite, but we have now. So we'll go over to the cyanide meter, put the bench light back on, switch the oscilloscope off and save electricity. I've got that down to about 4 dB so we're not saturating the receiver, and we'll go through the front end coils. No change. No change. No change. Go to a bigger signal for these. No change. No change. Tiny one there. So let's see where we are now for the sensitivity. I don't expect there'll be any change at all. There's 12 dB. It's 0.3 on that scale. It's 0.3 on that scale. No change. But I have done the detector. I was spot on. Right, S meter. So we'll go to 100 microvolt signal. Is it reading S9? Well, the answer is yes. So if I turn the signal generator up, it is going up eventually. Do we ever get plus 30 on this? Looks like we don't. I think we should be doing. Am I doing the squelch there? I am. That's upset the squelch. So I want plus 30 to just light. on my maximum signal generator setting. And there we are, S9 is S9, and we can get plus 30 to light, so that's a move in the right direction. Now then, I've upset the squelch control. I can hear it crying bitterly in the background. So if I turn squelch to full, I want to be able to try and squelch out S9. Bit more. There we are. That is S9. Show you on the attenuator control. So 100 microvolts, S9. So now we'll turn the squelch to minimum, turn the signal generator to 0.3 of a microvolt, and then put it to standby. Now then, we've got the dilemma that the radio isn't doing anything, which this chassis will do. So the squelch has come in when there's no signal present. But it is actually set right, believe it or not. So I'm going to set it to threshold. How do we guess threshold when... I'm going to have to upset this. We're going to have to weaken the maximum squelch. Mind you, that could be a bit dirty, so I'll just spray that. Right, set squelch. Switch the signal generator on. Straight in. So it's coming in at 0.19 microvolts, and it's leaving it 0.07 of a microvolt, which is very, very sensitive. But we have now spoilt the top end. So we turn the squelch to full. The maximum we can squelch out is 30 microvolts. But that's the best compromise I can do, and we all know the squelch is a letdown on this chassis. So that's it. That's where we are with it. We're done. So really, it's a matter of changing the ballast resistor and getting the 4 watts out. So I'll put the lid back on. And we'll test his microphone as well. You actually need to take the top off to get the bottom on. So I'll just put a couple of screws in here, because I know what's going to happen if I put all the screws in here. I'm going to open the set back up, aren't I, to adjust the deviation for his mic. I can just imagine that. Tell you what, we'll just put the one screw in, and then we'll get his mic plugged in. Now there were screws missing in the other mic, but there aren't in this. Wallow. Let's listen to it on my receiver. Wallow, testing 1 2, testing 1 2, testing wallow. It's absolutely fine. So we'll leave that on. Well, that was even hardly off frequency. So apart from the 3 watts to 4 watts, not really done anything to it. We will sort this power lead out behind the scenes. And while I go to church, I'll give that power lead to Mr. Chippy. But before we do that, we'll plug our aerial in and unplug the test equipment from the speaker socket. So it's Sunday afternoon, about 2 o'clock. One Nana Roger. Roger. So the bloke talking about 15 foot was probably 25 to 35 miles away. Yeah, I don't like the squelch on anything with this chassis. Right, we'll do an on-the-air test later on with that, and that concludes box number 3. So all being well, we can fit any CBs in tomorrow. We'll be starting on box number 4. Is that another SMC Oscar that's come, or is it a Cybernet Beta 1000? It's something like that. Thanks for watching Amstrad 900, a £79.99 radio from 1981.